Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Welcome to Lesson 7, Ethernet Switching. So in this lesson, we're going to be looking at Ethernet frames. We're going to be looking at the MAC address table, and the different ways that a switch will forward data. So remember, Ethernet frames happen at layer 2. They take a packet from layer 3 and they convert it into a data frame, depending on which technology layer 2 is using. This chapter is all about Ethernet, so that's the underlying technology we will be using. Ethernet actually operates at both layer 1 and layer 2. Part of layer 2, the data link layer, it's broken up into two subcategories, LLC and MAC. Important is it uses the IEEE code 802.2 for the LLC, and it uses 802.3, that's the main focus point for Ethernet, for the MAC sublayer and the physical layer. Again, the LLC sublayer, the 802.2, it places information in the frame to identify which network layer protocol is being used by the frame. Just like layer 2, it could be different network technologies. Layer 3 is the same way. We assume that it's going to be IP based. Doesn't have to be. Just like we assume layer 2 is going to be Ethernet based. Again, it doesn't have to be. The MAC sublayer is 802.3. That's going to be the predominant Ethernet. That's the wired connection. If we're talking wireless, it will be 802.11. If we're talking wireless personal area network, it will be 802.15. So again, it kind of really just depends. The LLC layer, again, allows higher layer identification, where the MAC sublayer is responsible for data encapsulation, media access, and it provides the data link addressing. That's going to be our physical addressing. So part of that data encapsulation process is taking a data frame, taking a IP packet from layer 3, or whatever layer 3 technology you're using, and we're putting a Ethernet frame together. And that means we're going to have the frame header, the overall structure. We have to have the addressing portion. That's going to be our physical addressing. And we have to have some type of error detection. That normally is going to be in the form of a frame check sequence number. And that will be used for, again, error detection. So the media access control, again, uses our physical addressing. But depending on the underlying physical connection, whether it's copper, whether it's fiber, it doesn't really matter all that much, because IEEE 802.3 is the overall MAC standard, and then we have certain subcategories of that, like 802.3U is fast Ethernet, 802.3Z is gigabit over fiber. If we're talking gigabit over copper, it's going to be 802.3AB. So again, Z versus AB, slightly different, both gigabit, but it's over different media. Because this is going to be what controls access to that media. Legacy Ethernet used a bus topology, point to point, meaning it had to have some way to detect errors, because it operated in half duplex. Duplex is actually if you can send and receive at the exact same time, or simultaneous. Normally, full duplex is the ability to send and receive simultaneously. Half duplex is one or the other. So when we're dealing with a shared media, we have to have some way to detect collisions. So Legacy Ethernet has this technology called carrier sensing multiple access collision detection, CSMA-CD. And essentially what this does is it allows for the detection of a collision on the medium. And if it is found that there is a collision, then a hold down timer, a random timer, would be placed so that they would pause transmission and try again at a later time. All gigabit connections are going to be full duplex, and Ethernet, when we're using switches, no longer requires CSMA-CD because each collision domain is tied per port, not tied to the entire device. CSMA-CD was very common when we had hub technology in place instead of switches. All right, moving on is our Ethernet frame. So our frame typically is between 64 and 518 bytes. If it is less than 64 bytes, it is a runt frame. If it is larger than 1518 bytes, it's a jumbo frame. Normally, if we're looking at errors, we're going to be looking at the first 64 bytes because that is where the normal errors would occur. The overall structure for an Ethernet frame is going to be a starting point, some type of preamble. Next will be the destination MAC address. Next will be the source MAC address. Then it will be the type and length of the overall frame. The type will actually dictate what type of layer 3 technology is being used. The data portion of a frame is actually a chunk from layer 3. That could be part of an IP packet, or it could be part of a packet. The type would actually let you know, is it an IP packet, is it some other form of layer 3 technology. And we will end with a frame check sequence number, again for error detection. The nice thing is, if a switch is sending a frame and it's too small or too large, then the other switches can drop it. Jumbo frames usually supported by most fast Ethernet and gigabit switches, but you have to have them configured. And again, a jumbo frame is larger than 1500 bytes. 1518 is kind of the limit. Above that would be a jumbo frame. All right, moving on. We have a lab. Labs are going to be explained in other videos. If you look at the description, you will have a playlist to where the labs are. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.